So we know that the minimum angular velocity is going to happen at the top. So what that means is this equation doesn't change. It's going to be the same equation, but for minimum, we want it where the tension becomes zero. When that's zero, so that the only thing changing the direction at 12 o'clock is the weight, then we can solve for the minimum. So it's the same equation, but to get the minimum, we make that zero. So we're going to get, so taking that equation up there, taking this equation and making that zero, and I'm going to replace that with mg. Even though I know the weight, I want to be able to cancel the m on both sides. So in part D, use a different color here. So in part D, I'm going to get that mg equals mv squared over r. So again, W is being replaced with mg, and I'm saying that the tension is zero because I'm trying to figure out the minimum velocity. Now, before I can get, well, actually, if I want to get it directly, I probably don't want to even use this equation because if we're solving for the minimum angular velocity, we are solving for omega in radians per second. So instead of doing this, I'm making an executive decision here. I'm going to change it to mg equals mr omega squared. That way, I won't have to do a conversion at the end. I can just, whatever I get from my omega, that's going to be the answer. And so you can see that the m's cancel out. And if I'm solving for omega, I'm going to move the r down here and take the square root. So all of the work is going to be omega is going to be equal to, I have the g divided by the r, and that would equal omega squared. So it's the square root. And that'll give me the minimum angular velocity. So again, you can see the work is not cluttered. That's all I have to do for part D. It's not like I had to do all these solutions, trig problems, and complicated math. So I'm going to have 9.8 meters per second squared, and I'm going to divide that by the radius, which was 0.7 meters. Now, again, if you look at this, you'll say my meters are going to cancel out, and I'm not going to have any units. I'm going to have nothing over seconds, because the second squared under a square root would make seconds, and these two are going to cancel out. But again, like I told you, that radian unit is one of these things that sometimes you ignore it, sometimes you have to put it in. And in this one, based on this, it's going to give me radians per second. So whatever that, if you solve that, I'm going to put the final answer over here, since this is where I have room. So the omega was what? 3 point something? 3.74 radians per second. So there's your answer for part D. And like I told you on the test, usually it's that D part that people mess up. Like they'll get part A, then they'll get part B, part C, and then they mess up on D. Usually on the test, I probably would not have like all 4 parts. Like if I had this problem on the test, maybe 2 or 3 of those parts would be there. I might ask what's the highest point, lowest point, and that, or maybe just highest point and that. But each part is worth 10 points. So what I just did here, that's 10 points. Just being able to, manipulate the formula.